Hi everyone, welcome back to my lecture on programming with Go. This lecture is the second part of getting started with Go. In the first part of getting started with Go, you have learned how to write a Hello World program in Go and how to run a simple Go program on your computer. In this second part of getting started with Go, you will learn how to run a Go program that uses external package and how to create an executable Go program. As in most of your programs in Java or other languages, you will often use code written by other people in your Go programs. When you need your code to do something that might have been implemented by someone else, you can look for a package that has functions you can use in your code. Such external packages are distributed or published in modules. You can use the pkg.go.dev website to find published modules whose packages have functions you can use in your old code. This diagram shows the organization of a Go code base. A Go code base can have or use several modules. Each module can contain several packages, and each package is a group of Go source files in the same directory. Let's consider an example of calling code in an external package. In this example, we want to print interesting messages using functions from an external module. To look for such a module, we visit the web page at pkg.go.dev and search for a code package. Then click on the first item on the list, that is code, open parentheses rsc.io slash code slash v4. At the top of the page for the code package, locate the package path rsc.io slash code. The v4 following the package path indicates version 4 of the package. By convention, the package name is the last element of the package path. In the documentation section of the page for the code package, under index, note the list of functions we can call from our code. We will use the first two functions in the list, so they are function glass and function go. Here is our new program, which is saved as mycode.go. In this program, in addition to the standard package fmt, we also import the external package code by placing its path between the double quotes after the keyword import. Then in the main function, we call two functions provided in the package code. So they are function go and the function glass that we found in the page for the package code earlier. In the Go programming language, to call a function provided in a package, we write the package name followed by a dot and the function name. For example, when we call the function println in the package fmt, so we write fmt.println and then pass the argument to the function after the function name in parentheses. And similarly, so here the functions go and class in the package code will return a string, and we want to pass that string as an argument to the function println so that we can see that string. And so here we call the function go in the code package by writing the package name, which is code, and then a dot, and then the function name. So the thing is, because the mycode.go use external package that is not a standard package, we cannot run it the same way we ran the hello world program or the hello.go program. So in particular, if you type go run mycode.go after moving to the directory containing this program, you will see the message saying mycode.go sig2 no required module provides a package rsc.io/code go.mode file not found in current directory or any parent directory. I see go have modules. Alright. So when your code uses external packages, such as in the mycode.go program, those packages become dependencies. So over time, you may need to upgrade them or replace them. So therefore, you need to enable dependency tracking in your code if you use external packages. There are two steps to track and manage the dependencies you add to your code. The first step is to put your code in its own module. This will create a go.mod file at the root of your source tree. Dependencies you add will be listed in that file. To add your code to its own module, use the go mode init command. For example, from the command line, change to your code's root directory and then run the command as in this example. The argument of the go mode init command is the path of your module. Note that the module path is not the same as the root directory of the code. If possible, the module path should be the repository location of your source code. If at first you don't know the module's eventual repository location, then you should use a safe substitute as discussed in the next slide. When you run the go mode init command to create a module for tracking dependency, you specify a module path that serves as the module's name. The module path becomes the import path prefix for packages in the module. The module path also creates a namespace for those package names. Be sure to specify a module path that won't conflict with the module path of other modules. At a minimum, a module path needs only indicate something about its origin, such as a company or author or owner name. But the path may also be more descriptive about what the module is or does. The module path is typically of the following form. That is a prefix, a forward slash, then a descriptive text. The prefix is typically a string that partially describes the model, such as a string that describes its origin. This may be the location of the repository where Go tools can find the module's source code, such as github.com. This is actually required if you are publishing the module. If you are not using a repository name, be sure to choose a prefix that you are confident won't be used by others. Another good choice is a name you control, such as your company's name. Avoid common terms such as utilities or apps, etc. For the descriptive text, a good choice would be a project name. Remember that package names carry most of the weight of describing functionality. Now let me show how to add mycode.go program to its own module. This is the first step to enable dependency tracking in mycode.go. It is done by first changing to the directory containing mycode.go, then running the go mod init command as in this slide as in this slide. Here we use go examples /code as the module path of the module containing mycode.go. Recall that the module path doesn't need to be the same as the path of the local directory containing the code. In particular, in Windows, the module path is still in the format of go examples /code. That is, we still have to use the / instead of / in the module path. Recall that the path of directory in Windows use the / to separate the subfolders instead of forward slashes. So this one is a module path which is independent of the local path of directory for the mycode.go. So now go examples /code is the name of the module that contains our mycode.go program. This go mod init command created the go.mod file in the same directory containing mycode.go. This go.mod file is simply a text file. Its initial content just includes the module path and the Go version. As you use Go tools to manage dependency, the tools will update the go.mod file so that it maintains a current list of your dependency. In the step 2, to enable dependency tracking in your code, you have to add module requirements and sums using the go mod tidy command. This command creates a go.sum file that contains checksums of the modules you depend on. Goals use this to verify the integrity of downloaded module files, especially for other developers working on your project. You need to include the go.mod and go.sum files in the repository with your code. Here is the example of go mod tidy with my code.go program on Mac OS or Linux. At this point, we are still in the same directory of mycode.go and have created the go.mod file for mycode.go program. When we ran go mode tidy, it located and downloaded the rsc.io/code module that contains the package we imported. By default, it downloaded the latest version, which is v1.5.2. When the Go mode tidy is completed, we can now run the mycode.go program using the go run command. Here we can simply type the period instead of mycode.go as the argument to the go run command, because this command will run all the Go program in the current directory, and that's only mycode.go in the current directory. Now I'm going to demonstrate how to enable dependency tracking in mycode.go program. This program is placed in the folder demo, which is in the folder Go examples, and Go examples is in the home folder or home directory of the current user, which is htding. So now I'm going to open the terminal on Mac OS, and when you first open the terminal on Mac OS, it's likely that you are in the home directory of the current user. So you can check it by using the ls command, and you see that here it lists Go example as one of the folders. Okay, so now we need to move to the demo folder that contains the mycode.go, and here we use command cd go example/demo. Okay, so now we are in the demo folder, which contains a mycode.go program, and if we try to run mycode.go program like the way that we did with hello.go, then it wouldn't work. So let's try. So go run mycode.go, and let's see. So you see that it cannot find this external package, so we cannot run mycode.go without enable dependency tracking in it. So the first step to enable dependency tracking is to run the go mode init command, and here we can give the module's name as go example code, go example/code. This is the module path or the name of the module that will contain mycode.go. Okay? And recall that this module path is independent of the path of the local directories of mycode.go. And we click this one, and so after we run this go mode init command, you see that it create the go.mode file, and so now let's click on go.mode file and to see what happened. Okay, so try to open it with because it's a text file, so I should open it with a text files, a text editor. So let's find the text edit. Okay, and then open. Alright, so this is content of the go.mode file that has been created. Alright, so the next step is to run the go mode tidy. So we type go mode tidy. Okay. So this Go mode tidy will download the module source code, and it will also create the go.sum file. Okay, so the go.sum file has been created after the go mode tidy command completes, and we can also click on it to see what it is. So this one should be open with a text edit as well. So here, okay, so we open it with any text editor. So this is the content of the go.sum file. Okay. We don't want to modify it manually, so we just don't touch it. So now we can run the mycode.go program by using the command go run, and here you can type go run mycode.go, or you can just type go run and the dot, which will run all of the Go program in the current folder. But the current folder has only one program, which is mycode.go. So we type go run dot and then hit enter. Okay, so this is the output of mycode.go program. So there you go. Once you are importing packages from a published module, you can add that module to manage as a dependency by using the go-get command. This go-get command does the following. First, if needed, it adds required directives to your go.mode file for modules needed to build packages named on the argument of the go-get command. A required directive tracks the minimum version of a module that your module depends on. Second, if needed, it downloads module source code so that you can compile packages that depend on them. The command also authenticates its module it downloads. This ensures that the module is unchanged from when it was published. If the module has changed since it was published, for example, the developer changed the contents of the commit, then Go tools will present a security error. This authentication check protects you from modules that might have been tampered with. The following describes a few examples. The first example is to add all dependencies for a package in your module. You simply run the go-get command with the dot as its argument. The dot refers to the package in the current directory. The second example is to add a specific dependency. So here you specify its module path as an argument to the go-get command. It can download modules from a module proxy like proxy.golang.org, or directly from version controls repositories. You can set the location from which Go tools downloads modules. Finally, you may want to create an executable Go program. This can be done by using the Go build command. For example, to create an executable program from mycode.go program, we first move to the directory containing mycode.go program. Then we run the command go build mycode.go. When the command is done, the executable program named mycode is created, and you can simply type mycode the command line to run the program. So this is the output of the my code program. So we have covered everything we need to get started with Go, including running and compiling a Go program or create an executable Go program. For more details, you may want to read these Go documents. For example, you can read the tutorial, Get Started with Go, and managing dependencies and managing model source documents.